So now that we have an idea of what we mean by an exchange step, that is to say, we have some system of linear equations that expresses some relationship between two variables, in this case uv, and two other variables, in this case xy, right? And what we saw in the exchange step was that we were going to exchange one variable for another, okay? And so what we did was we exchanged here the u and the x, and you can see here it's u and here it's x. So that's what we mean by an exchange. And so there's this special thing that we're going to use that's going to allow us to, instead of writing down a linear system like this, just as you might use matrices, right? You could also use something that Neff calls an exchange tableau, okay? And it's like this. Let's say I have in general a set of equations y1 equals to, let's say, a11 x1 plus dot 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 plus, let's say, a1 n xn, okay? And then I go all the way down. Let's say I have m equations. This is a m1 x1 plus a mn x to the n, okay? So I have this set of linear equations, right? So this would be the obvious generalization of something like this, right? And what we can do is we can express this as follows. I can make a horizontal line and a vertical line like this. In these columns, I'm going to put my variables x1, x2, all the way to xn. And in this column, I'm sure you guys are already getting it, you're going to see the y1, the y2, dot dot dot, ym. And on the inside here, you're going to just see the coefficients. a11, a12, a1n, am1, amn, and of course, all of this will be filled in with the corresponding terms that is given by the system. Okay? And so then, once we have set up this exchange tableau, we'll be able to perform the same exchange that we saw here, but we're going to perform that exchange using the special exchange rules, which I'm about to write down for you. Okay? So unfortunately here the rules didn't quite fit entirely, and you can find these on page 54 of Walter Neff's book, The Linear Algebra. And but once I perform a couple of examples, this will be the first example I'm going to perform. I'm going to redo this using this exchange step rules. It will make sense to you. Okay? So the first thing that we do is that we add a row, which we're going to call the seller row, with a blank under the pivotal column, and in which the rest of the row consists of the coefficients of the pivotal row divided by the pivot and multiplied by -1. We're going to replace the pivot in the new tableau with its reciprocal. Okay? We're going to replace the pivotal row, like the rest of the pivotal row in the new table, with the members of the seller row. We're going to divide the pivotal column by the pivot, and then we're going to add the product of the seller row and the pivotal column to every other remaining coefficient. Okay? So let me demonstrate that here with this example. First, I'm going to make my tableau, my exchange tableau for this case. Okay? My variables here are u, v, and x and y. And in other words, what I'm saying is that the tableau corresponding to this set of system of linear equations is this one: 3, 4, 2, -3. So in other words, okay. So in other words, let me get rid of this bottom part. Okay. So in other words, this tableau can be read to represent a system like this. Okay? I can see that x is equal to 3u plus 4v, and I can see that y is equal to 2u minus 3v. Okay? So now I'm going to perform the exchange step to exchange the variable x with the variable u. Okay? And of course, we already know what the answer should be over here. Okay? So but in doing this, I'm going to be able to show you how to read these rules and how to perform this calculation. Okay? And then we'll look at a couple more examples. Okay? So this will be our pivot. Why is this one our pivot? Because I want to exchange the x with the u. Okay? Okay. So what I'm going to do is I'm going to add this thing down here. This is my cellar row. Okay? Just like a cellar where you put wine to drink, it's a cellar. It's in the bottom. Okay? We leave a blank in the cellar row underneath the pivot, so I can put a star there if you want. Okay? And on the other, and in the other spaces, but in this case there's only one other space, the one under the 4. What do I place there? I place the other members of the pivotal row, of the pivotal row, divided by the pivot, and then multiplied by -1. 4 divided by 3 is 4/3, times -1 is minus 4/3, like this. Okay? So now, once I have done that, I'm ready to go into my the tableau I'm making, which will represent the exchange. Okay? So now I'm going to have exchanged these vectors once I fill in this table. Not these vectors, these variables. So I'm going to place my x here. I'm going to keep my v here because it has not been exchanged. My u is going to be here now. And my y is going to be here because I haven't exchanged that one. And then, now I can follow the rest of the rules. I'm going to replace the pivot with its reciprocal. I'm going to replace the 3 with its reciprocal. What is that? 1/3. I'm going to replace the pivotal row, what's left of it, with the cellar row. Well, in this case, this value here would be the -4/3. But of course, if there had been more terms in the pivotal row, they would have gone in there, right? Okay, if it had been with more variables. Okay. Then, for the rest of the pivotal column, I'm going to replace each term with the term divided by the pivot. In this case, 2 divided by 3. 2/3. Okay? And then finally, we're going to the final rule, which is we're going to add the product of the cellar row with the corresponding member of the pivotal column to all the remaining coefficients. In this case, there's only one remaining coefficient. So it'll be -4/3 times 2, which is -8/3, plus the -3. Well, that's going to become -8/3 plus -3 is -8/3 minus 3, which is -8/3 minus 9/3, which is -17/3. And so you see, I end up exactly with what I was expecting. Okay? And so this is our first view of how to use the rules for an exchange step to actually perform the exchange of variables. Okay? And so what I want you to realize from this is that the rules for the exchange step that Walter Neff wrote down, don't take mine, take the one from his book because he wrote it much better. But this is good enough for us, is that he observed what happened when you solved a system. He stepped back from that, realized I can abstract it into these rules, and then by applying these rules, I can duplicate the calculation, but without involving the messiness, if you want to say it about that, if you want to think of it that way, of actually looking at the equations the way we did originally. Now, the way we did it originally was fine if we're with a 2x2 system or maybe even a 3x3 system. But I think you can see here that this is a very clean technique, okay? And anyway, it intrigued me, and so I'm super excited to hopefully explain it to you all. We're gonna leave this example behind us for now, and I want to perform a different example for you all so that you guys can see it being used for some purpose, okay? I hope you've enjoyed this, and I look forward to seeing you again soon. Thank you so much.